Hello. We have yet another way to write equations for lines. This is point slope form and it comes in handy, well, you'll see when we're given a point and the slope of a line. So I just want you to see where it comes from. You almost don't even have to write this part down. I don't want you to think it just comes out of nowhere. So that was the formula for the slope of the line between the points x1, y1 and x2, y2. We're just going to rearrange that a little bit. Namely, we're going to multiply both sides by that denominator, so it just clears out the denominator on the right side, and on the left side we have m times x2 minus x1. And then we say, okay, this is like for two specific points, but we just want it to be one point. So we just let one of those, we let x2, y2 just be any generic other point on the line. And it becomes that. So that's it. That's point slope form that you'll come to know and love. It's m times x minus x1 equals y minus y1. And yeah, I think you're going to need to memorize that for the next exam. So as the name indicates, if I give you a point on a line and the slope of that line, this is the easiest way to give me an equation for the line. I'll summarize at the end so you don't get the three different ways to write a line confused. Okay, so this is the type of question we can answer now. Find the equation in slope-intercept form, so that's mx plus b, for the line through the point negative 2, 4, having slope negative 3/2. So, we could go ahead and sketch that line now. We could plot the point and then go, how we do it. We go like down 3 and over 2. But we're not asked to sketch it. We're asked for an equation for it. And this is the fastest way to do it. And it lets us bust out point slope form. Okay, so m is negative 3/2. And our x1, y1 is negative 2, 4. So the name is good because the name kind of cues you when to use it. Okay, so stick all that stuff in. We have negative 3/2 on x minus negative 2, so remember we're looking at that, equals y minus 4. Now, if I just asked you for an equation, you could technically stop now. That is an equation for the line. But it's messy, and also I didn't. I asked for it in slope-intercept form. So you kind of have to remember what that is. So we want it as y equals mx plus b. And to do that, we just basically solve it for y. So we clean it up as best we can and then just get y on one side. Minus negative 2 is the same as plus 2. You could have jumped right there. You know that x minus negative 2 is the same as x plus 2. So that's fine. And then we're just going to distribute. That's negative 3/2 x. Let's see, negative 3/2 times 2 is just negative 3. And then just go ahead and add the 4 to both sides. And I flipped it around as well. I just like to see it as y equals mx plus b, not mx plus b equals y. So it's y equals negative 3/2 x plus 1. Okay, and then just look at the graph. We weren't asked to graph, but just to confirm that it looks the way you think it should look. It goes through the point 2, 4, there it is, and it has slope negative 3, 2. So that means we go over 2 and down 3, right? So if you just graphed it to begin with, you maybe could have figured out, okay, this is the y-intercept here, but you don't know for sure that it's 1. It could be like 1.1. And either way, this is a not very difficult way to do it. So given a point in the slope, now I know everything I need to know about the line. I know the slope and the intercept, and I can just write it in this. This is, like I said, this is the main way we're going to write equations for lines. This is slope-intercept. Just one more. So here's something we haven't done yet. Find an equation for the line through the points negative 1, 4 and 1, negative 2. So if you just look at it, so those are the points. There's negative 1, 4, and there's 1, negative 2. You could very easily just draw the line now. It just is the only line that goes to those 2 points. Think about what the slope should be, though. It should be pretty negative. And then the y-intercept, well, it's kind of hard to tell without drawing it, but it's going to be in here somewhere, right? So we have an extra step here. So a problem exactly like this will definitely be on the exam because you have to use everything. So first we need the slope between those 2 points. We can't use point slope form yet because we don't have the slope. So use the m equals y2 minus y1 over x2 minus x1. Like that. So -2 minus 4 over 1 minus -1. And then remember, if you flipped them around and did 4 minus -2 over -1 minus 1, you would get the same exact number. So there's no rule that says which point to use. Okay, so -2 minus 4 is -6. 1 minus -1 is 2. And -6 is -3. So we said the slope should be pretty negative, and it is. And, you know, you could see, okay, we go over 1 and down 3, basically. Okay, now we are not done. Now we have to use point slope form, and here's an important part. It shouldn't matter which point you use now. So now it's like we have more information than we need. We have the slope and we have 2 different points. But I promise you that no matter which point you use, you will get the same equation. It will look a little different, but you'll get equivalent equations. And then if you've moved it around and got it in slope-intercept form, you'd get the same answer no matter what, okay? So there's no reason to use one point over the other. I think I'm just going to use the first one because it's first. All right, so it's m times x minus x1 equals y minus y1. So -3 times x minus -1 equals y minus 4. Okay, let's just change that x minus -1 to an x plus 1. It's just ugly. We don't like to see redundant stuff like that. And then now here's a hot tip. Go back to the beginning, to the setup of the problem. So we always want to make sure we're doing everything we're asked. So I just said find an equation. I didn't say find the equation in slope-intercept form. So technically we're done. Now you could put it in slope-intercept form in order to graph it. That would actually be pretty easy to do. And then you could just make sure that it looked right. So it looks like the y-intercept is in fact 1, and if you just, you know, clean that up a little bit, you would see that. And it certainly wouldn't be wrong to do it that way if you just liked it. But, you know, you don't really want to do more work than you have to. So if I just say, if I give you a, you know, point and a slope, and I just say find an equation, just pop it in point slope form, and there you go. That's an equation. Well, let me just sum up. So there's 3 different ways to write an equation for a line. Sorry. So I'm just going to summarize it so you remember. Ax plus by equals c is called standard form. Now, it's funny because you'll almost never see that because I never use it. It's great for like graphing using intercepts. And honestly, that's all it's really great for. Okay, so for whatever reason, it's called standard form. This is the main form. So the main form you're going to see is y equals mx plus b. And it's like that because then it's like when we get into functions, we want y as a function of x, which is down the road. But it's just nice because you just have the y on one side. So just y on one side is slope-intercept, and then you get that nice information from that. You get the slope and the intercept, okay? Hence the name. All right, and the one we literally just talked about 2 seconds ago is point slope form. So I will ask you stuff on the test like, you know, leave your answer in slope-intercept form, or, you know, find the slope, then blah, blah, blah. So you do kind of just have to remember what that is, and that's all. So I know lines are not the most thrilling topic in math, but we know pretty much all we need to know about them now. Thank you.